So now what are we going to do? We'll try and see if we can make up some laws. Let's follow the thread along with people like Galileo and Einstein and Newton and all these people, and let's see if we can create some laws that this world will obey. The world around us will obey. And you already know that this chapter is called Force and Laws of Motion. So there is a plural over there somewhere. So you kind of believe that there are laws, right? You might even know that there is Newton's first law, second law, third law. Yeah, we are here to tell you there's only one law. And if you stick with us, we'll teach you what that one law is. And second, also that Newton's first law is not really Newton's first law. It's kind of one of those little places where they all cheat us, they all lie to us. So let's try and understand what all these are. Let's start off from our old Aristotelian argument. The natural state of things is to be at rest. Is that true? Let's say that is true, for example. Let us just believe that it's true. Then let's say you see somebody moving, right? This was the question that everybody had on their mind. Now you might say his state is moving. Therefore, in some situation, someday he has to come and be at rest, right? Someday he has to come back to rest. Great. But what will he be thinking? He will look at you and he will say that, hey, you're moving. Someday you will come to rest. Which of them is right? Are you moving or is he moving? If you stand in a train and the next train starts moving, the train right next to you, almost everybody in the world starts looking out, right? Thinking, okay, am I the one who's moving or is that other train? We all get confused. So the Aristotelian argument kind of had a flaw somewhere because we don't really know who is moving. And the fact that Galileo began to start observing things in the real life in a slightly more deeper manner than had been done before made him realize something very, very insightful. And that was a huge breakthrough because he said, the natural state of things is not to come at rest because we don't even know what rest is. But if you let some object be, it'll keep going in whatever velocity it has. In other words, he says, if you give a body some velocity, it'll retain that velocity until and unless somebody does something to it. Now, how did he kind of propound this? If you think about it, what he said was, he had a very simple argument. Let me take a little sloped surface, an inclined plane, I drop a ball from it, right? It's going to go down. And if I keep another inclined plane here, it's going to slide down and go up that. We all know this, right? Now, let me just reduce that incline a little bit, the right one. What's going to happen? He saw that this ball goes down and goes almost the same height where it started from. Yeah, of course, sometimes it doesn't go as much. We call that friction, but it almost went there. Now, let's imagine you reduce the spine, kind of the slight even more. Then it goes to the same height even now. So then he asked the question, right? Till here it's observable, it's reality, but this is where the jump from reality to imagination comes. Now he said, if I make the second slope so low that it's flat, then in order to come to the same height, which the ball always wants to do, how far must it go? What is the answer? It has to go forever and ever and ever and ever and ever. It was an argument that he gave to prove what? Or to kind of make people understand what? If you give a body some velocity, we do observe it to be coming at rest all around us. But he said if there is no friction, as they called it. What is friction? When a surface you try to move above, one surface tries to move above another surface, there is some relative motion here and friction tries to stop that because of some bond formation. So if that is not there, if you assume that is very, very, very less, he said the object will keep going on forever and ever and ever and ever. But just because he said this, does it make it true? Because most people said, hey, I won't believe you, right? I throw this, it stops. He said, but there is friction. But then they asked the question, if there is no friction, how are you so sure it'll keep going on forever? And are we sure? We really aren't, right? We have sent out something called the Voyager into the sky, right? Out into space. And it's kind of not yet stopped today. But does that mean we have proved that it keeps going on forever and ever and ever? It passed Jupiter a few years ago. It passed the solar system a few years ago. It's still not stopped. Does that mean Galileo was right? It means that he was probably right, because if it has not stopped till now, what could make it stop later? But still, people can argue, right? They can say, no, it's not stopped for 150 years, but how do you know it won't stop next year? What if the natural state of things is to come to rest? The truth is, we don't know. In other words, we don't really know, we can't really prove it, but the more and more we see around us, the more and more it makes us believe that if there is no friction, things will keep going on forever and ever and ever. And this can be attributed to Galileo because he was the first person who had the insight to kind of point it out to us. He said, no, things won't stop. They keep going on forever and ever and ever until somebody stops them. And he said in most of our real life situations, somebody does stop them. And who are they? We call them friction. The force that stops objects, we call them friction.